All right. So as we proceed forward further into this week, okay, uh, you're going to be allotted some time to work on your papers. That's written down on the board. So coming up tomorrow, what's expected of you tomorrow? And I'm not going to keep doing this because one of the things we get further on, again, we say that you're in high school. Tomorrow, what's important about that? What you have assigned to you is due. That's correct. Okay. And something I want you to keep in mind is that when you turn these assignments in, okay, it people are gone. I get that. People are sick. There's appointments that you need to go through. But if it's one of those aspects to where if you don't have it done, okay, chances are it might take me a little bit longer to get it back to yourself if it gets shuffled in with other papers. So I'll just keep that in mind. Also, I would suggest that you keep those papers when they're handed back to you to look at for problem quizzes in your exam and to make sure that it's been graded. I may go through the entire class and there's a grade on there, but for some reason got skipped putting on Infinite Campus. So that's just a good idea to make sure you have a hold of that it's graded. And then all you got to do, can you recognize your own handwriting? Do you think someone can forge that pretty easy? They could? Okay. So then all you have to do is just say, hey, it was 50 points. It says 48 on here, but it says missing. And it's a real easy fix, pretty simple. So just keep that in mind. Make sure you maybe hold on to them until it has been put in the grade book, and then wait till we get to the end of the chapter. That's your personal choice. Some people tend to put those papers in the circular file. If you know what that means, that's a garbage can. That's where sometimes they end up. But that would be your choice. And then again, if you miss time or you're not here or something's assigned, please get in and talk to me so you don't fall behind. Okay? Because there's nothing worse than trying to play catch up when maybe you've missed a couple of days, and it's not because of your fault. Maybe it's because you're sick. Okay, and that does happen. So should that happen, please come in, talk to myself. We'll get you straightened out. Okay. So we have just a little bit of information to cover, and then we'll talk a little bit about momentum, and then we'll get you on your way. All right, so what's the main difference between a balanced and an unbalanced force? Just what results between the two? I mean, what's going to happen if the force is unbalanced? It's going to go one way or the other. Okay, that's correct. And if it's a balanced force, well then there will be no net movement. So yes, you are correct. Okay. So one of the aspects that goes into when we start talking about forces is that will be another formula that will be given to you, but that is next chapter, because we don't really want to throw a whole lot of information at you right away at once. I really don't believe in that. Let's just take a nice slow progression so we're nice and comfortable with this material and keep moving forward. All right. So I think we have just one left. This one, oh, no, two. And then I think we're done. Okay, fair enough. So this one is where we left off with, correct? Yeah. Okay, and then finally, here we're talking about, as you can see, that of inertia. So I think in that speed video, they were talking about race cars, okay? And that was in, not so much in drag racing, but in the other form, which they're just going in a circle. Some of you maybe live for Sunday afternoons in late February, in March, because I don't know a lot about the racing, but it's different or just the opposite to that of football. Because with football, all your weeks are leading to the end result, which is called the what? The Super Bowl. That's separate from racing. Because in racing, what happens, like for instance, approximately the last Sunday in February, it's a specific race. The Daytona 500, which is the biggest race, starts out big and then starts to break apart into, um, what is it, Winston Cup Series. And for those of you who maybe follow racing, I think it's kind of neat how much horsepower these vehicles can put out, but that's about where my interest kind of ends. That's just me, because everyone's going to have probably their own opinion when it comes to sports. To me, if you really want to know the race, you just watch the last 10 minutes. But some people, you might know who that is. And that's fine, great, good for them. Sit there all day. We know anybody like that, or maybe that's one of you people. And yeah, to each their own. But someone could say the same thing about, for instance, tonight when with baseball, as I think Minnesota's in Chicago. I think that's right. So someone could say the same thing. Just wait to the ninth inning, then you can see the end there. So, or the fourth quarter, or but some of you maybe like to see the events leading up to that. But and yeah, maybe they want to see the crashes. That's right. That's felt them on my fingertip. Darn it! In my old age, I'm not as fast as I used to be. So. Which you runners are doing quite well, because man, you know, I always explain it's just the opposite when it comes to whether you call it a helium balloon. You let that go, it gets further and further up. But in this case, we start running, you people keep getting further and further ahead, and that's the way it should be. So, and that's great. Okay. So finally, when we're talking about those, the example we gave with that race cars, that's coming around a curve. That car is actually trying to do what? It's trying to go out. So a good driver, okay, will maintain control of that vehicle. Does anyone in here like sad movies? Well, not that you like sad movies, but I think everyone likes dog movies. It's called The Art of Racing in the Rain, I think is what it's called. And it's about a golden retriever dog, and the main character talks about many of the crashes that take place occur when the driver is not expecting to go into a skid. So this movie's going forward, he talks about he causes the skid. Okay, so that way you know what to expect. Okay, and I think there's probably something to be said for that. So if you actually know you're going to go into a skid before it happens, you're probably not going to have such a problem with this, where that inertia is trying to push you further out. So if you can maintain that control, it's going to help you out quite a bit. Because I think what happens is a panic mode can set in, to where if you don't have that option to come to a stop. I just remember this summer was mowing around a tee box down in Del Rapids. It was a pine tree. And if you know anything about some of this new equipment, it's got a roll bar on it. And some small utility tractors have roll bars on them too. And what that means is if you're strapped in, it has a bar that goes across the top. So unfortunately, should that piece of equipment get tipped over, that roll bar is going to keep that from crushing you as an individual. But sometimes gets in the way, because you might forget about it, because it's still above where you're sitting, about almost 2 feet. But anyway, going around this tee box, there's a pine tree that had a branch that was sticking out this way and then sticking, almost made a 90-degree angle. And getting in there, I almost got that roll bar wedged in there where I go about what seemed like 2 inches forward or 2 inches back. I had it wedged in there. I said, how am I going to get this out of here? Because for one thing, the steering is actually on the back 2 wheels, so it's going to feel different when you're turning those, and rather as opposed to the front wheels. So one of the things that could happen is kind of like, oh, if a person just panics, they start going forward and backwards, you're going to start breaking things apart. So where it's just kind of stop. Okay, think, what do we need to do? So you turn the wheels one way, swing the tail end, okay, stop, back up. Before that, turn the wheels another way, and then pull forward out of there, rather than just being they say a bull in a china shop, just knocking things over. Like I said, bad things can happen with that. So again, are we good drivers in the winter time, do we think? Or maybe you haven't had that much experience yet? Yes? No? There's nothing wrong with going 5 miles an hour slower. And I think you would agree with that. So otherwise, when some of these cars can skid, that certainly can cause problems with that. But anyway, inertia. Resistance change that motion of that vehicle. That weight of that race car going around a curve is trying to push that into the wall. But then a good driver would have that under control. Okay. Does everyone have this information that wants it? Okay, so what we want to do next is as follows. You're going to want to find your formula sheet, okay, and add this to your paper, okay? You know, a smart guy would probably erase this right away so they don't have to do this in the following class, but okay, so the formula that we want you to write down, you can use any variable that you want, but the author goes on to state P for product, okay? So a product of an object's mass, okay? So this equals that object's mass times its velocity, okay? If you really want to be specific, you can do that, okay? So the reason we say that, an object has to be in motion, and it can't be the initial velocity because it has not run into anything yet. So that's why it has to be the final velocity. So if you just wanted to use m, that's fine. What problem might you have with that? What do you see on the right-hand side? An M there too. So one of the things you can do if you wanted to, so you don't get it mixed up, maybe make a capital M equals the mass times the velocity, whatever it is that you feel most comfortable with. All right. So how do we utilize this? Well, for instance, I think we talked about some of you farmers that you might have to go through where it's a little muddy. You might thinking, do I really want to go through there? If I do, I probably better have enough speed to get through so I don't get stuck. Has anyone gotten stuck before in a tractor? Okay, and at work I got stuck 3 times. Okay, so what's that like? You get stuck. Got to get the phone out. And who are we calling? Okay, we got to call Dad. Are we thinking, I really don't want to make this phone call? So that's going through your mind. Okay, so darn, I told you not to do. I don't know if that's what that sounds like, but I'm just picking on you. But does that maybe sound familiar? I told you not to get that close. Oh, it's It's worse than that. Okay. So, as long as it only happens once, right? I don't know. But it happened to me 3 times, so don't feel bad. But the second and third time, I was just doing what I was told to do. I said, "Oh, I think you can get through there. You'll be all right." Well, down it goes. And of course, it's a lot different than a tractor because there isn't nearly enough power in these things to really push their way through. But anyway, so with this, we will say a tractor has a mass of, I guess I don't know how much a tractor weighs. We're going to say probably some, moving at, okay, so what is the momentum? Okay, so we got the right idea because we're solving for this. So we've read the problem, okay? And then once you've done that, what should your next step be? Write down the information or write down what we know. So, in this case, what do we know in this problem? The mass equals 2170 kilograms. What else do we know? And then what are we ultimately solving for? The product or the momentum. Okay, so again, those two variables are intertwined. What do we want to know? The momentum, which is the variable P. All right, so pretty straightforward. Just do what the formula tells you to do. So we're taking the variable P or the product, and that's going to equal what? Whatever these two are times each other. So it doesn't matter if you flip-flop the two. So 7.14. Okay, and again, you don't have to put the labels in there because we've accounted for them over here. So once we have done that, we can proceed forward. So what is the momentum? All right, and I didn't leave enough room to label that. This is what we call a derived unit, okay? So what we mean by derived is something that comes from another term. And to make sense of that, the best example I can come up with is when we look at element number 26, okay, on the periodic table, okay? When we look at a lot of these elements, they're named after the first letter, maybe the first 2 letters, or 2 letters in the name. So element 26 is iron. Well, that must be the letter I, right? No? Well, maybe it's IR for iron. Maybe it's, well, iron's got an I and an N in it. Agreed? Yeah, it's actually Fe. It's not iodine, iridium, or indolium. We have Fe. And what that means is this is a Latin term, okay? Ferrous means iron in Latin, okay? So this term is derived. It comes from the Latin language. So when we say this is a derived unit, it comes from the multiplication of these. So therefore, that is labeled in the mass is measured in what? in this problem. Kg or kilograms, okay? This is the label. And then we also have what's velocity measured in. Meters per second. So this isn't a minus sign, it's just dash. So kilograms per meter over seconds. That's your label for momentums. It's a mass per unit velocity. So kilograms per meter over second. Again, that's just derived from these two units. And I'm not all, I don't get all bent out of shape if you miss a label here or there or mislabel it. If it's every problem, then we're going to have issues. But it's one of them things to where if you get it, catch it right away, it's just going to become more simpler for yourself. So, any problems with this? Left outside, are we good? Left middle, middle, right middle, right out, right, okay, right outside. Are we good? Okay, I just either thumbs up or nodding our heads and then we proceed forward. Okay, now, okay, this is why writing these things down is always going to be more beneficial for you. Okay, so for instance, trying to think of something that's dropping out of the sky all of a sudden. I suppose we could say a hailstone. Anybody have any hail damage on your crops that you're aware of? It's very easy to see. It just unfortunately some of the farmers that are going to collect insurance on that got to take a stock chopper and knock it all down. So I believe that's if you take the insurance, you got to do that. Really seems too bad, but that's just a unfortunate side effect of the weather. So, for instance, what would you think would lead to lethality of a hailstone? About what size? Walking outside, a hailstone coming down. Oh boy, that could be dangerous. What size? I would say probably golf ball, depending where it hits. If it just hits you on the side, that's gonna hurt. But it's probably not gonna be. But if it hits you on the top of the head, yeah, you're certainly gonna notice that, and that could be a problem. Has anyone ever been caught out in a hailstorm? I think maybe some of us have. Depending upon the size, that hurts. I think these were just dime sized. That was working on the grounds crew for the baseball team down in Sioux Falls. There was a bad storm. The only reason I remember that is I think your sister was a junior or senior at that time. They had a volleyball tournament up in Esteline. Because isn't that how the volleyball season starts? Usually there's a tournament in Esteline every year. Maybe that's changed. Do you have to pick? So what would you pick? And I'm looking past yourself, but you could probably do both, right? Yeah. Okay. Anyway, back to this. So we got this hailstone. Oh, I would venture to think, we'll say golf ball size, I would venture to think, we'll say 3.5 kilogram. No, that's probably pretty big. We'll go 2.5. This, I'm throwing it to the wolves here. This is a difficult problem. That's why we're working on this together. All right. So this is one of those aspects to where you need to kind of read between the lines and take the solution in one part of a problem and place it into another. Okay? So this is where one of those aspects to where we might not like math, but we're good at it. That's going to help you out here immensely. Okay? And this is where when students choose not to write down the information that they know, problems can arise from this. How many of you are looking at this and saying, this is really, really difficult? And I would expect a lot of hands to go up. Okay? How many of you are thinking, oh gosh, this looks terrible? Yeah, okay, and that's fine. Again, that's what I would expect. That's why we want to work on something like this together. Okay. So, therefore, again, you've read the problem. What should you do next? Yes, write down what we know. So, what do we know in this problem? Okay, so we know the time, which was what? Okay, what else did we know? Okay, that's very important. Yep. So, initial velocity. As we're looking at this, what's true about that hailstone right now? And where's it located? Way up there. However long 12.15 seconds is up in the sky. Give or take. Oh. Okay. Well, we'll see. That's a low-lying cloud, isn't it? Yeah. Which is, I can't really judge distances because when a lot of this weather is occurring, you can see if you have a cell phone tower, at one moment it's there, another moment a front is moving through it, and you can't see the top of it. So with this, one of the things we need to find is where what our final velocity is. So what we see happening, there is some other information that we can put in here. And okay, that's important too. And we have the mass as well. So mass equals 2.50 kilograms. And then one of the things we want you to do is look at what's the question really asking? What's the momentum? But before we get that, this is giving you a clue right here. If it's dropping out of the sky, what did we talk about yesterday? What's this doing? A lot of you had said it. We've got an acceleration, which you had said is 9.8. And don't do that, or don't stop there, because if you do, what problem could arise from that? You don't have to erase anything here. We're missing something. Yes, this is meters per second squared. Because if you don't put that in there, you're jotting this down, you might think, oh, this is our velocity. No, it's the acceleration. Okay, so this is where you correctly said we need to find that because it's asking for the momentum. But what two things do we need to know to solve for a momentum and mass? Well, according to this formula, like you correctly said, we're looking for this guy, We've got that, but we don't have him. But do we have enough information that we could solve for that final velocity? And the answer would be yes. And again, this is why you have that formula sheet. This is why you write down this information that you know, because when we combine this and this and this, what can we solve for? You correctly said your final velocity, okay? So, 9.8 equals what's on our right-hand side. You got to look at your acceleration formula. And, okay, well, you're saying correct information, but you're not putting it in the right spot. Final velocity, okay? And we don't have to put that there. We can, but it's just the variable. And then finally, what goes on the bottom? 12.15. Okay. Are we doing all right so far? Left outside, are you with us? Left middle. Middle. Okay? And, okay? Right middle. Right outside. All right. So, how do you think we get this guy all by himself? Right, and to do that, we've seen that before. You can cross multiply here. We can put this number over 1. There's absolutely nothing wrong with that. So, if there was a number here, we could say 1 times a number gives you what? The same number. So, that logic would say take 1 times a variable, that would just be what? VF, or the final velocity, by cross multiplying here, and you correctly said we're going to cross multiply there. So the final velocity equals what? 119.7, and we're labeling that how? We are? Who's squaring it? Oh, it happens. But you know, if I was reading through that and saw meters per second squared, there are some things that are really, really important. Then there are other things that are just okay. They know what they're doing. It's just a silly mistake. We can live with that, okay? Because sometimes in volleyball, your opponent might be out of place. This is how little I know. Some of you ladies, you're probably good at this. It's passed to you. Then you're setting it. I really think a good hitter, aren't you approaching, looking where the defense is, and oh geez, they're way back. I'm just gonna do a little tip to get it over the net. Does that sound about right? Okay. So one of the things that it's a busted play on their end. So that's a good catch on yourself, but so what? That's going to happen through the course of a game. Maybe in football you run the wrong play, but still ends up being a touchdown. That happens. You might get the right result, but you started with the wrong process. Yeah, like I said, I'm not too hung up on that. This is really what I'm looking for right here. So now, if we have our final velocity in here, now we can take it times 2.50. I guess I probably should have put this down here too, so that way you can see that we're looking for 2 unknowns. But you correctly said take 2.50 times 119 and then 257. Okay, And again, that's kilograms dash meter per second. All right. Now, some of these problems, this doesn't look like it's a long one, but you're taking information from one formula and putting it into another one. So that's why, please write down the information that you know, and you'll have a better chance of being successful. All right. Left outside, are we good? Left middle. Middle. Right middle. Right outside. Now, unless you're sitting on the end here, look to your left, look to your right. You got people around you that can help you. Okay? You're not in this alone. All right? So, should you have problems, take advantage of the Science Channel. Take advantage of working with your classmates and asking questions. Please do that. Okay, so with what's expected of you tomorrow, is anybody lost with what's on there? Is there anything you want to ask before we leave in 5 minutes? Yes? 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 That is... That's tomorrow. Yeah, both of them are due tomorrow. Yep. Okay. Yes.
I have a question on the tables.
Okay.
If it's straight, it's constant, right?
That's correct.
And then if it's like curved, it would be average.
That would be acceleration, yes. Average acceleration, that'd be fine. Average, yep. And this would not be average acceleration, it'd be average something else. Average speed. Yep.
Is this acceleration since it goes up?
Nope. Because acceleration would be a curved line. Yep. So that could not be, it's not curved, so it would be average. Average speed. That's correct.
Oh, never mind. I had that.
Okay. So, some terms, get them done by tomorrow. These papers done by tomorrow, and then that's correct. Yes. Then I won't get in trouble for losing them, which is quite possible. All right. We'll catch up with you next time.